Alrighty, 3-4, linear programming. Linear programming is a process that lots and lots of, almost every business uses, quite frankly, because they want to know what should they produce so that they're producing exactly the right amount so that people will use all of it and they won't have anything sitting there. And they want to maximize their profit and they want to minimize their costs. So that's what we're going to look at today for linear programming. And we're going to come back to this problem, but I want to read it to you now because I think this would be a great idea for somebody who says, you know what, I want a summer job, but, can you smell? Got it? Okay. I want a summer job, but I don't want to do anything normal. I want to work for myself, do something on my own. This person is going to try to raise money by selling tomatoes. So they want to spend no more than $40, got kind of a low budget, but part of that is because they don't have enough room for more than 15 tomato plants. Tomato plants need a little bit of space so that they get enough food and water. And you want to maximize the pounds of tomatoes you'll get because that's how people pay for tomatoes. You know, there's always little scales everywhere that help you pay for your tomatoes. And how many of each plant should you buy and justify your answer? So we're going to come back to this one after we figure out how this whole process works. And the first one that we have here is called testing vertices. So what we're going to do is go through section 3.1 where we had to do graphing. And sometimes we used our graphing calculator to figure out where lines hit each other. We are going to look at a little bit of 3.2, which was how do you do this algebraically? How do you make sure that, you know, the points work? And then 3 is a big part of this because that was getting our lines on there, dashed or solid, and doing the shading. That's huge. And then we'll put it together with like 2 more little steps and we'll be done. So what point in the feasible region maximize P, which usually stands for profit, for this objective function? Now, objectives are what you're trying to reach. So the business, for whatever reason, these might be in millions of dollars, makes $2 million off of product X and $1 million off of product Y. And they want to know, where should we do this? I mean, if we can hire people and produce as many as possible, should we do that? How will we maximize our profit if we do? So the first thing we have to do is we have to graph what are called constraints. Constraints are the things that hold you back. In the tomato plants, it would be you only have $40 and you only have room for 15 plants. Those are constraints. You can't just keep buying. You don't have room for them. But in this problem, they came to us already pre-made. So I'm going to color code. That top one, I'm going to do green. And just like we did for section 3.3, we're going to find the zeros when it's in standard form. So we pretend for a second that it says x plus 2y equals 5. And then we say, all right, if x is 0, oh, I'd have to divide both sides by 2. That'll be 5 halves, or 2.5. If I don't have any of the y's, if this is 0, x is going to have to be 5 for this to say 5 equals 5. So those are the 2 points that I used to graph, 0, 2.5, 5, 0. And then I realize, oh, it's solid. It has an equals bar. Then I check. Will 0, 0 work? I'm testing that point. And it would say 0 plus 0 is less than or equal to 5. Yep, that works. So I can shade down for the green line. So that's the first constraint right there. That's holding them back from being able to make how many ever they want out here. They can't do that. Then I switch colors, and I'm going to go after the second constraint. X minus y is less than or equal to 2. Again, it's in standard form, but it has a negative, so I have to be a little extra careful here. So if x is 0, this is going to say the negative of something is 2. The negative of something is 2. What would that something have to be? Yeah, it'd have to be negative 2. The other one works out a little nicer because we have a negative 0, but that doesn't make any sense. And it'd just be 2, because 2 minus 0 would be 2. So we graph at 0, negative 2, and 2, 0. We hit our pause button and say, ooh, that is solid. That one had an equals bar too. And again, I test 0, 0. 0 minus 0 is less than or equal to 2. Well, of course it is. 0 is less than or equal to 2. I shade towards 0, 0, which for the red line means up. And then I switch colors one more time. And I go to the fancy thing, the column is the obligatory constraints. Now, what that means is we are obligated to put these last two on here. I'm using blue for those two. Because you can't have a negative of a product. So we have to tell people, x has to be greater than or equal to 0, y has to be greater than or equal to 0. You can't use negatives. On my graph, I'm just going to do this. I'm going to cut it off so that everybody can see it's in quadrant 1. And now my job is to go back and look in quadrant 1 and figure out, where do I have red overlapping with green? Where is that? Now, up till now, we haven't used any new skills. All of that was from 3.3. So here come the skills, but they're not new. They're something we already know how to do. In fact, this next part you knew how to do in geometry. We have to find the vertices. So of this little figure, which happens to be a quadrilateral, we have to figure out where are these little pointy spots where everything hit each other. That's what we have to find. And there's good news. 3 of them we already know because we graphed them. We've got 0, 0. This one was our green one, which was 0, 5 halves, or 0, 2.5, because with word problems it doesn't matter if you use decimals or not. Most money is in decimals, for goodness sake. This one I know on my red line, that was 2, 0. I only have one I'm a little bit worried about. That's because I didn't use a ruler. I think it's at 3, 1. So I'm going to put a little question mark by that one because I should really check. I need to know where that's located at. So this is where we do a little bit of section 3.2. I'm going to check and make sure that this is right by checking it in both the green and the red one. If it equals 5 and it equals 2, then it is the answer and I can erase my little question mark. So if I put 3 here and 1 here, will it say 5 equals 5? So it checks with the first one. If I put 3 here and 1 here, will I get exactly 2? It's a go. I'm going to strike out my question mark. It worked in both. I already know it's greater than or equal to 0, so that doesn't make any difference. Now here's another thing that we do that we already have the skills for. Now that I know where they're at, I'm supposed to figure out, when I put those x's and y's into this, which one kicks out the biggest profit? So P equals 2x plus y. And I'm just going to use a little arrow here to show, hey, I plugged these in, and this is what I got. So if I put 0 and 0 in here, 2 times 0 plus 0 is 0. I highly doubt that is going to be where the most profit is made. Then I put in 0 and 5 halves. That's going to give me 5 halves, or in this case I'm going to write 2.5 because I want everybody to remember you can use decimals with word problems. It's okay. 2, 0. 2 times 2 is 4. 4 plus 0 is 4. So far, that's been our highest. But along comes 3, 1. 2 times 3 is 6. 6 plus 1 is 7. And like I said, that might be $7 million profit, you know. So the biggest number was kicked out by 3 and 1. That means they should produce 3 of product X and 1 of product Y, and that will maximize their profits. So back up here, it was multiple choice. And it's 3, 1. Now, if we look at all of those vertices, we say, well, we did all that graphing, and look, they had them all 4 right here. Well, we didn't know that when we started. No. So now we have completed a linear programming problem, except they usually come as word problems. So we have to write those constraints, write the objective function, and then go through all these steps, and we'll be able to figure out where do we maximize, where do we minimize. So usually if they want you to do profit, it's P equals. If they want you to do costs, they use a capital C. And they say, where is the lowest amount of costs for us? Either way, they'll tell you, they'll let you know in a sentence. 1A says, use those constraints that you found in problem 1. Good. That means we don't have to graph everything all over again. Just change your objective function to P equals X plus 3Y. And what they really want us to see is, if that objective function changes, well, our choice is probably going to change as well. So we're going to put in our 0, 0, our 0, 5 halves, or 2.5, 2, 0, and 3, 1. But we're putting those into this new objective function. What do we get if we put 0 and 0 in this thing? 0, yeah, again, that's, probably not going to maximize business if you don't sell any of anything. That just makes sense. And then if we put 5 halves in there, or 2.5, we're going to get 7.5. It's 3 times $2.50 would be $7.50. Go ahead and put 2, 0 in there so I can check and make sure you're able to do this. What would you get? 2. Go ahead and put 3 and 1 in there. What do you get? Did our maximum change? It did. Now it would be 7.5, whether that's millions of dollars or whatever it is, and it would be produced at 0, 5 halves. Now that might be, it depends on whether or not you can really do half of a product for this company, whether or not they would produce there or not. Now B, this we're going to have to wait until our 3rd day on this section to talk about this one. Can an objective function P equals AX plus BY plus C, can it have the same maximum value at all 4 vertices, Q, R, S, and T? At points R and S only, and explain using examples. We might not come back to that one. That one might confuse people. But, like I said, we're not there yet. We've got a little bit more to do. Which brings us back to the tomatoes. So what we want to do with our tomatoes is figure out the constraints, the things that are holding us back, the things that we don't have unlimited supplies of. And I want to use totals to do that. So when you read through that problem, what's one total that hits you right away? 40 bucks. Are you willing to spend more than 40 bucks? Reading this problem. No. Exactly 40? That would be okay. So less than or equal to 40. Now remember, this one was all about money. So we need to go find something else about money up here that involves the Roma and the cherry tomatoes. Do you see the money? It's in the advertisement, isn't it? Yeah. Now, it's up to you if you want to use X's and Y's. I'm going to use R's and C's. So 2 R's plus 3 C's is less than or equal to 40. And all of that was about money. So that's why it's important that we look at the label for the total. What was the other total in there? 15, yeah, because tomato plants take space. And you want to make sure you're able to get as much out of those plants as you can. So you don't have an unlimited space. That's going to be less than or equal to again. Does it say you want to get 3 times as many cherry tomatoes as Roma tomatoes? twice as many Romas as cherries, anything in there that lets us know something about how many. Then we just put x plus y, or r plus c in this case. Finally, we have to put these in here because this is a word problem. Can you go to the greenhouse and say, I was going to buy 3 plants today, but I decided not to. Give me my money back. They're going to look at you like you're a nut. You can't get a negative amount. So r is greater than or equal to 0, and c is greater than or equal to 0. So like I said, we're obligated to put those on to tell people, hey, yes, we realize you can't buy a negative amount of this. Now, we also need an objective function. How to write that was actually in the problem, because it says you want to maximize the pounds of tomatoes. So I think I'll use P. But since that was about pounds, and that's my total, there must be some other stuff about pounds up here that I didn't notice before. Do you see it? 8 pounds for Romas, 10 for cherry. There they are. So now we're going to do exactly what we did in the non-word problem a little bit ago. We're going to graph our constraints, find the vertices, put them in the objective function, and figure out how many of each we should get. All right, color coding time. I think I'll keep that top one green. So now, it's in standard form. I want to find the zeros. Let's see, if I don't buy any Romas, I'd have to divide by 3, and that'll be 40/3. But I want to know where that is because I don't have any numbers on my graph yet. So let's see, 3 goes into 40, 13 and 1/3 times? Yeah, 39. 39 is the closest we can get. This one's a little bit easier. If we don't buy any of the cherry tomatoes, how many Romas can we get? Yeah, 20, because 2 times 20 would be 40. Now, I don't know that those are the numbers that I should use for my graph yet, because I don't know about the other constraint. So I better figure out the other one. I'm going to change colors and do r plus c is less than or equal to 15. Oh, well, that makes this part really easy, doesn't it? If you want 15 plants and you don't buy any Romas, how many cherries do you have to get? Yeah, and vice versa, right? Okay. Well, and it looks like the biggest number we have to be able to get to is 20, which is fabulous, because this is a little 20 by 20 graph. So I think I'm going to label 1, 2, 3, 4 in 5s. And I'll put Roma 1, 2, 3, 4, 5. Sideways. I suppose we can put the label Maters up there at the top. Or tomato plants or something along those lines. You ready to graph? Remember, let's color code. So I'm doing my green one now. That's 0, 13 1/3, and 20, 0. And we did have equals bars. What we didn't have was an unlimited amount of money. So we can't shade out here where all the big numbers are. Gotta shade back here. And you could always test 0, 0. You know, 0, 0 is going to work. 0 plus 0 is less than or equal to 40. It's good. And then I want to switch colors. Mine was red. And do my 0, 15, and 15, 0. Could we take care of a big, huge number of tomato plants? Didn't have the space for it, did we? So that's going to be shading back this way too, towards 0, 0. And then I know that those last two just mean that we graphed this very well because we are just in the first quadrant. So now we're going to go back and look, and we're going to see, where do we have overlapping red and green in the first quadrant? And again, if you're feeling like, this is 3-3, Cedar Home, you're exactly right. Up to this point, this is section 3-3. That's what we did. Now we have to figure out where the vertices are. And again, we're going to know almost all of them. We know where this one is. We know where this one is. And we know where this one is. The problem is this one right here. So I definitely know this is 0, 0. And I definitely know this was at the end of my green line. That's why color coding is so valuable. My green line was 0 and 40/3. This was at the end of my red line, which was 15, 0. And then I have that last one. And I didn't use a ruler. And I didn't necessarily draw it straight. So without some kind of help, whether it's algebra or the graphing calculator, it's going to be really hard for me to know exactly where those two hit each other. We're going to use our graphing calculator and be sure. But to do that, we have to have these solved for y. So this is sometimes why people say, I'm not ever using R's and C's, S's and T's, anything like that, because I want to see the x and the y for my graphing calculator. Just remember, the first one is your x and the second one is your y. Be perfectly fine. So let's solve for y. Let's get c all by itself. 3c will equal negative 2r plus 40. And I'm going to do equals because I want my graphing calculator to see where these lines hit each other. Oh, I need that space though. We're going to put one more vertex there. And then I'll divide by 3. So c equals negative 2/3 r plus 40/3. So that's going to be one of the equations I put in my graphing calculator. This one is super easy to get c by itself. All we have to do is subtract r. So I've got two of them that are going in my GC. That little bugger right there, and this little bugger right there, so that my pet Blinky can tell me where they're hitting each other. Everybody have them down? Okay, so if you have a graphing calculator, you can put this along along with me. Don't forget that your Chromebook has the TI-84 Plus app, or you can just watch me do it up here. So, y equals parentheses negative 2/3 parentheses x plus parentheses 40 divided by 3 parentheses. Double check. Will you double check for me? That's what that one was, right? You wrote it down because I'm not in section 4. Yeah. And the other one is negative x plus 15. We already know what the window has to be. We already graphed this. So if we go into window, 0 to 20 for the x's, 0 to 20 for the y's. That's exactly what we had on our little graph. And then we'll hit graph. And now, it's been a few days. Where is my hypoallergenic pet, Blinky the cursor? Excellent. Second, trace. Number 5, intersect. There's Blinky. How you doing, Blinky? Long time no see. Now, you can move Blinky a little closer to the intersection if you want to. Blinky has to do less work when you do that. Or you just hit enter 3 times. Look at that. Touch of a button, Blinky says, buy 5 of the Roma and 10 of the cherry. Good going, Blinkster. And I got to tell you, that would not have been what I wrote down if I guessed mine. Mine would have been more like 7.5, 8.5, or something like that, because it's not straight. So it's really, really helped. Did anybody get it right on? Did anybody see 510 on the graph? Like perfect? Yeah, without rulers, it's really hard to do that. Well, we're almost done. We just have to put this into our objective function and find the one that gives us the most pounds of meters, because that's how you're going to sell them. You sell them by the pound. Well, pretty obviously 0 and 0 gives us 0 pounds of tomatoes. I always think that's just so silly. That would minimize your cost, though. You wouldn't have to put any money out to produce that. And then 0 and 40/3. Well, let me plop that up here so we can see it as a decimal too. So 40/3 times 10. I'm hitting the right buttons. I don't have my glasses on. 133.33333333. So 133.3 repeating. Put a 15 in there. 8 times 15. 120. And then a 5 and a 10. 40 plus 100. What's your maximum pounds of meters? Yeah, 140 pounds with 5 Romas and 10 cherries. I don't know if I left myself anywhere to write that. Some space up here? Sure, I'll write it up here. 5 Roma and 10 cherry tomato plants. Maximize pounds at 140. I kept thinking when I taught this 3rd hour, I'm pretty sure that I know they were $3.99 a pound at Cub for the, doggone it. It's the tomatoes that are grown right here in Minnesota. It starts with a B. Big boy tomatoes. So let's see how much money you would make at $3.99 a pound times 140 pounds. Ooh! It's all summer long, weeding and watering. But still a pretty good amount of money if you sold all your tomatoes. And then maybe you could, expand next year and rent a little farmland and really make this into a business. So that is one problem. That is a linear programming problem. Because in business, they're not just going to have 4 constraints. They might have problems that have 12 constraints at a time. And they have to figure out, how do we maximize profit? We're not going to do those. They usually use software for theirs. One of the other things that I wanted to make sure that you know, because they do put one of these in the homework, is how to graph that. Because it seemed to kind of throw people for a loop in 3rd hour. You want to look at this and say, okay, x has to be between -2 and 2. Where would that be? Well, x is -2 right here. And it's +2 right here. And you see how x is sandwiched between those two? So that's where your shading goes. I always wait until I teach that to one class, and if they totally get it, then I don't have to go over it. But it looked like 3rd hour was a little bit stumped by that, so I wanted to make sure that you remember how to graph those. All right, so here comes your whopper of an assignment. Right there. A lot? No. Probably, I would say at least 3. Because we had a bunch of those. I'm going to get a squirt here and then bring you guys some graph paper. We had the dimes and quarter type problems. So you should expect to see one of those because we did more than one of those. What else? There was another one that gave us combinations. I think one was about muffins or something too. Yeah, so we should expect a couple of problems like that from section 3-2. And then obviously we'll have at least one of these, at least. We'll only be able to put one of these on the test. Yeah, you're welcome. Let's take 3 days and have a test on just this one section. You're welcome. Yeah, not all of these 6 problems that you see up here are word problems. You know, they're just, hey, graph and find the vertices and plug them in like the other examples we did. And I should check, but I'm pretty sure that I did all of the word problems that get assigned from this section on FAQ videos. Oh, I better turn this off.